Hello everyone and welcome back to the Math Simplified by HM channel. Currently we are diving into the fascinating world of triangles. Pause as you needed to understand and create your own notes. Before starting today's session, I request all of you to subscribe our Math Simplified by HM channel. Today we are looking at a truly elegant property of a triangle, the angle bisector theorem. If you have ever wondered how bisecting an angle affects the opposite side of a triangle, this is the video for you. Let us jump right in and prove it mathematically. The theorem statement: the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the corresponding sides containing the angle. Here, in the triangle ABC, ray AD bisect the angle BAC. Then, according to theorem statement, AB upon AC is equal to BD upon DC. Now, let us set up our proof. We are given triangle ABC and AD is the internal bisector of angle BAC. As AD is internal bisector of angle BAC, we know that angle BAD is equal to angle DAC. What we need to prove is that the ratio of the split base BD upon DC is exactly equal to the ratio of the remaining two sides of the triangle ABC, that is AB upon AC. So we have to prove AB upon AC is equal to BD upon DC. To prove AB upon AC is equal to BD upon DC, we need a clever geometrical trick. For that, a construction is required. We are going to draw a line from point C parallel to angle bisector AD in upward direction. Then we extend side BA such that it will intersect our parallel line at point E. This creates a large new triangle BCE, which allows us to use parallel line properties. Now let us look at the angles created by our parallel lines BA and C. First, taking BE as a transversal for this line AD and CE, we get angle BED is equal to angle AEC, corresponding angles. So this is our first pair. Then taking AC as a transversal, we get angle DAC is equal to angle ACE, alternate angles property. So in this step, we have seen the angle relationships. We are going to use these relationships in our further proof. Now we find the isosceles connection in our diagram. We have shown that angle BAD is equal to angle AEC and angle DAC is equal to angle ACE, and angle BAD is equal to angle DAC is given in theorem statement. As this forms the left sides of these equations, it clearly indicates that angle AEC is equal to angle ACE. Now see in a diagram, angle AEC is equal to angle ACE. Therefore, this angle AEC is a isosceles triangle, and by isosceles triangle property, the sides opposite to congruent angles are congruent. Therefore, we get segment AC is equal to segment AE. Now Let us zoom out and look at the giant triangle we created, BCE. In this triangle, side CE is parallel to line AD. So, by basic proportionality theorem, the sides are divided proportionally. Hence, BA upon AE is equal to BD upon DC. Now, we are one step away. What we have to prove? By basic proportionality theorem, we have BA upon AC is equal to BD upon DC. And in step 2, by isosceles triangle property, we have A is equal to AC. From these two, replacing AE with AC, we get AB upon AC is equal to BD upon DC. Hence, we have proved the angle bisector theorem. When we do that, we get our final result. Here, to prove this, we have used basic proportionality theorem and isosceles triangle property. We may prove this also by area ratio property along with angle bisector property, which every point on the bisector of an angle is equidistant from the sides of the angle. Thank you so much for watching and keep practicing your geometry. Before leaving, please share this video to your colleagues, like this video, click the bell icon, and lastly, if you have not subscribed still, please subscribe the channel to get you our upcoming videos. Thank you again and again. Have a nice time.